Our planet Earth is a place of incredible diversity. It boasts lush rainforests teeming with life, vast oceans holding untold mysteries, and scorching deserts where survival is a daily challenge. Yet there are also corners of our world where the conditions are so extreme they test the very limits of what we thought possible. Imagine a place where the air itself can freeze, a landscape sculpted not by water, but by unimaginable cold. This is the realm of Earth's coldest spot, a silent, frozen wilderness where nature presents its most formidable face. It is a world unlike any other found on the surface of our globe, a true testament to the power of the elements. The search for the absolute coldest point on Earth takes us to a continent of superlatives, Antarctica. This vast landmass, larger than Europe, is almost entirely covered by a colossal ice sheet. It is the highest, driest, windiest, and indeed the coldest continent. Deep within its interior, far from the moderating influence of any ocean, lies the true heart of the cold. Here, specifically on the high East Antarctic Plateau, temperatures plummet to levels that are difficult for us, accustomed to more temperate climates, to truly comprehend. This is where the coldest natural temperatures on our planet's surface have ever been recorded, a place of stark, icy beauty. This polar desert is a place of profound stillness, yet it is also a place of constant subtle change. As the ice slowly shifts and the winds, though sometimes calm, can also be incredibly fierce. The landscape is deceptively simple, an apparently endless expanse of white snow and ice stretching in every direction. However, beneath this seemingly uniform surface lie complex geological features and ancient secrets trapped within the ice itself. The very air here feels different, thin and crisp, and the silence can be overwhelming, broken only by the whisper of the wind or the distant crack of shifting ice. It is a world defined by ice, a substance so dominant it shapes every aspect of the environment. The journey to understanding this extreme environment is a journey into the heart of winter itself, a perpetual winter that lasts for months on end. The sun disappears below the horizon for extended periods, plunging the land into a deep, dark polar night. It is during this prolonged darkness, combined with other geographical factors, that the temperatures reach their most astonishing lows. We are drawn to such places not just for their extremes, but for what they can teach us about our planet, its history, and the remarkable resilience of life itself, even in the most inhospitable conditions imaginable. This land challenges our understanding and beckons explorers and scientists alike. The coldest regions on Earth are not just randomly scattered. They are found in very specific locations dictated by a combination of powerful natural forces. The East Antarctic Plateau, a vast high-altitude dome of ice, is the undisputed champion of cold. Within this plateau, areas such as Dome Argus and Dome Fuji, along with the Russian research station Vostok, consistently record the lowest temperatures. Vostok Station, for instance, is situated about 1,300 kilometers from the geographic South Pole, at an elevation of nearly 3,500 meters, or about 11,480 feet above sea level. This great height means the air is thinner and holds less warmth from the start. Several key factors contribute to the extreme cold experienced in this part of Antarctica. Firstly, its high elevation means it is further from the denser, warmer air found closer to sea level. Secondly, its interior continental location, far removed from the temperature-moderating effects of the Southern Ocean, prevents any significant oceanic warmth from reaching it. Thirdly, during the long Antarctic winter, the region experiences months of continuous darkness known as the polar night. Without any sunlight to warm the surface, the ground radiates any stored heat out into space, causing temperatures to drop relentlessly, day after day, for many weeks on end. Another significant factor is the presence of very clear skies and dry air. Water vapor in the atmosphere can trap heat, acting like a blanket. However, the air over the East Antarctic Plateau is exceptionally dry, meaning there is very little of this insulating blanket effect. This allows even more heat to escape into the vastness of space, further cooling the surface. Furthermore, the high, smooth ice sheet itself reflects a large proportion of incoming solar radiation back into space, even during the periods when the sun is present, limiting how much the surface can warm up. This reflective quality is known as its albedo. Finally, the shape of the ice sheet plays a role. cold, dense air pools in depressions on the plateau. Sometimes this super chilled air can flow downhill as katabatic winds, which are winds driven by gravity. While these winds can sometimes mix the air slightly, the persistent conditions of high altitude, continental isolation, prolonged darkness, and clear, dry air combine to create the perfect recipe for the most extreme cold found anywhere on our planet's surface. It is a delicate balance of powerful natural processes, all working together to create this uniquely frigid environment, a true natural laboratory for studying cold. The temperatures recorded in these frigid Antarctic locations are truly staggering, pushing the boundaries of what we might imagine terrestrial environments can experience. At Vostok Station on July 21, 1983, the mercury plunged to an astonishing minus 89.2 degrees Celsius, which is minus 128.6 degrees Fahrenheit. This remained the lowest directly measured air temperature on Earth for decades. More recently, satellite data has indicated even colder potential ground temperatures in shallow depressions on the East Antarctic Plateau, particularly near Dome Argus and Dome Fuji, with readings dipping below minus 93 degrees Celsius or minus 135 Fahrenheit on several occasions. These are temperatures where exposed skin would freeze almost instantly. Measuring such extreme cold requires specialized instruments and techniques. Traditional mercury thermometers would freeze solid, so alcohol thermometers or platinum resistance thermometers are used at ground stations like Vostok. These devices can accurately record temperatures far below the freezing point of mercury. For broader coverage, scientists increasingly rely on satellite remote sensing. Instruments on satellites such as MODIS, the Moderate Resolution Imaging Spectroradiometer, on NASA's Terra and Aqua satellites, can measure the thermal radiation emitted from the Earth's surface, allowing them to estimate ground temperatures over vast, inaccessible areas, revealing these incredibly cold pockets that might otherwise go undiscovered by ground teams. One might assume that such an intensely cold environment would be entirely devoid of life, a sterile wasteland. However, nature often surprises us with its tenacity. While larger animals and plants cannot survive these conditions on the high plateau itself, the world of microscopic life tells a different story. Deep beneath the several kilometers of ice that blanket much of Antarctica lie subglacial lakes, the most famous being Lake Vostok. Here, in perpetual darkness and under immense pressure, scientists have found evidence of microbial life bacteria and archaea, known as extremophiles, uniquely adapted to survive in conditions that would be lethal to most other organisms, a truly remarkable feat. These hardy microbes have likely evolved unique biochemical pathways to cope with the extreme cold, low nutrient levels and high pressure. They may metabolize minerals from the surrounding rock or utilize chemicals dissolved in the water. On the fringes of the coldest areas, where conditions are marginally less severe, one might find very hardy lichens, algae or fungi colonizing exposed rock nunataks, small mountain peaks that poke through the ice. However, the high interior plateau itself remains a domain primarily for these specialized microorganisms, a stark reminder that life in its simplest forms can find a foothold in even the most seemingly inhospitable corners of our amazing planet. For humans, visiting or conducting research in Earth's coldest spot presents a formidable array of challenges that test the limits of endurance and technology. The extreme cold poses a constant threat of severe frostbite and hypothermia, requiring specialized multi-layered clothing and heated shelters. Machinery and scientific equipment are also vulnerable. Plastics can become brittle and shatter, lubricants can freeze solid, and batteries can lose their charge very rapidly. Even simple tasks become incredibly difficult when bundled in heavy gear and battling the biting wind, requiring careful planning and execution for every single activity undertaken by brave researchers. Beyond the physical dangers of the cold, the isolation itself is a significant psychological challenge for those stationed there. Research stations like Vostok are incredibly remote, cut off from the outside world for many months during the long, dark Antarctic winter. Supply lines are tenuous and rely on complex logistics, often involving long-distance ski-equipped aircraft flights. Communication can be difficult, and medical emergencies require incredible resilience and ingenuity from the small crews. The combination of extreme cold, prolonged darkness, and isolation creates one of the most demanding working environments imaginable on the surface of our planet, testing human spirit. Despite these immense difficulties, the scientific importance of studying this extremely cold region cannot be overstated. The vast Antarctic ice sheet acts as a frozen archive of Earth's past climate and atmospheric conditions. By drilling deep into the ice, scientists can extract ice cores, which are long cylinders of ice that contain trapped air bubbles, dust, and chemical isotopes from millennia past. These ice cores provide an invaluable, direct record of past temperatures, atmospheric composition, like carbon dioxide and methane levels, volcanic eruptions, and other environmental changes stretching back hundreds of thousands, even over a million years into our planet's deep history. This information is crucial for understanding natural climate variability, the impact of human activities on the current climate, and for improving our models of future climate change. Furthermore, the study of extremophile life in subglacial environments like Lake Vostok offers insights into the limits of life on Earth and has implications for the search for life on other icy moons or planets in our solar system. An interesting fact is that Lake Vostok, buried nearly 4 kilometers or about 2.5 miles beneath the East Antarctic ice sheet, has remained isolated from Earth's atmosphere for potentially millions of years, making it a unique, pristine environment for scientific discovery, a hidden world beneath the ice.